I want you to picture a scenario. You're sitting at your computer, it's late, and you're trying to get a really specific, messy answer out of an AI.
Hmm.
And I don't mean asking for a recipe, or what is the capital of Peru? I mean the kind of question that requires connecting about a dozen scattered dots across a massive amount of text.
Right, like trying to solve a cold case investigation using only a chatbot.
That is the perfect vibe. Let's say you feed it the entire text of Charles Dickens' A Christmas Carol,
Okay.
and you ask something like, trace the exact causal chain that leads to Scrooge's transformation, specifically focusing on how the poverty of Victorian London acts as a catalyst for the supernatural events.
That is quite the mouthful.
Yeah.
And usually the AI gives you a very confident, very well-written answer that is completely surface level.
It's frustratingly polite. It mentions fog. It mentions ghosts. It mentions Scrooge being grumpy.
All the keywords.
Exactly. But it misses the why. It misses the thread connecting the setting to the psychology to the plot. It feels like a student who skimmed the Wikipedia summary 5 minutes before the exam.
And is just trying to bluff their way through that feeling, that flatness. That is the single biggest bottleneck in the AI industry right now.
Right.
And it's exactly why we're doing this deep dive today.
Right.
We are witnessing a massive architectural shift in how AI retrieves information. We're moving from the standard RAG retrieval-augmented generation.
There's something much more complex and, frankly, much cooler called GraphRAG.
Exactly.
GraphRAG. It sounds like a geometry problem I would have failed in high school. But before we get into the new stuff, we have to clarify the old stuff. Standard RAG is basically just a search engine glued to a chatbot, isn't it?
In a nutshell, yes. Think of standard RAG as a high-speed Trudel plus F on a massive document. You ask a question, and the system hunts for keywords. Scrooge, London, transformation. It finds the paragraphs where those words appear, pastes them into the prompt, and tells the AI, here, answer the question using this text.
Which works fine if the answer is sitting nicely in one paragraph.
Sure.
But if the answer relies on understanding that a comment in Chapter 1 caused a subtle emotion in Chapter 3, which resulted in a decision in Chapter 5, Schrod plus F is useless.
It completely misses the bigger picture. It treats the book as a bag of unconnected sentences.
And that's where GraphRAG comes in.
That's where it comes in. If standard RAG is a keyword search, GraphRAG is that detective's wall you see in crime movies.
The corkboard with the photos and the red yarn connecting everything.
That's the one. It's not just looking for clues, it's physically pinning down the relationships between them. It mapped how person A knows person B, or how event X triggered event Y. It captures the structure of the story, not just the words.
I love that visual. So instead of just finding words, it's finding the red string. And looking at the stack of research we have on the desk today, this isn't just one company trying to sell a product. This is a massive wave of research. We have papers on Fast GraphRAG, LightRAG, StructRAG, KET-RAG, and something called HippoRAG too.
It's quite the lineup. And our mission today is to figure out how these technologies are solving the three things that keep AI engineers up at night: cost, speed, and the elusive reasoning.
We're effectively looking at how we give AI a human-like long-term memory.
That's the goal.
So let's start with the problem you mentioned earlier, that flatness, the inability to connect the dots. We have a paper here on StructRAG from late 2024 that is pretty brutal in its assessment.
They don't pull any punches. The researchers identify what they call the scattered information issue. They argue that standard RAG relies on flat data representations.
Right.
And when you have a knowledge-intensive reasoning task, the useful information is often, to quote the paper, badly scattered across different documents.
Badly scattered sounds like my desktop file system. But why is that fatal for an AI? Can't it just read all the scattered parts?
Not effectively. I mean, if the AI retrieves 3 random chunks of text that don't clearly link to each other, it generates a fragmented answer.
So it's like memorizing 3 random dates from a history book versus actually understanding the timeline of the war.
That's a perfect way to put it. So StructRAG proposes that we need to fix the data before the AI even sees it.
So we're talking about pre-processing. How do they do that?
Well, they took a page out of cognitive theory, literally. They looked at how humans process information. We don't just memorize raw data, we convert it into structures. StructRAG does the same. It analyzes the raw info and decides, is this best represented as a table, a timeline, a knowledge graph? It structures the data to fit the problem.
So it's acting like a smart study guide. Instead of handing the AI the textbook, it hands over a timeline and a mind map and says, study this.
That's the intuition. It creates a hybrid structure. By formatting the data correctly, the AI can perform what they call global reasoning. It stops looking at sentences and starts looking at the logic holding them together.
That makes a ton of sense. But StructRAG seems to focus on how we prep the data. There's another paper in the stack, LightRAG, that attacks the problem from a different angle. The retrieval itself.
Right.
They talk about a dual-level retrieval system. What's that about?
LightRAG is interesting because it acknowledges that sometimes you do need the specific details.
Of course.
If I ask, what color was Scrooge's scarf? You don't need a complex graph, you just need the text. But if I ask, how does the scarf symbolize his frugal nature? You need the concept.
So LightRAG tries to do both. It's trying to have its cake and eat it too.
It tries and it succeeds. It indexes the low-level details, so specific facts, and the high-level concepts, the abstract themes, simultaneously.
Ah, okay.
Standard RAG is usually stuck in the weeds of low-level details. LightRAG ensures the answer is comprehensive by looking at the forest and the trees at the same time.
Okay, so we know why we need this. We need the detective wall because flat text is too scattered. But I want to understand what is physically happening under the hood. We have the documentation for Fast GraphRAG here. Let's stick with the Christmas Carol example.
Let's do it.
When I feed the book into this system, it's not just chopping it into paragraphs, is it?
No, and this is the magic part where the graph gets built. It uses an LLM to read the text and extract entities.
Entities, so proper nouns. Scrooge, Bob Cratchit, London.
It starts there. Characters, places. But it goes deeper. It extracts objects like Scrooge's ledger.
Okay.
And even abstract concepts like greed or redemption. Once it has these entities, the pushpins for our detective wall, it starts drawing the strings. It identifies the relationships.
So it reads a sentence and realizes Scrooge employs Bob Cratchit, or Marley's ghost warns Scrooge.
It labels that relationship explicitly. It builds a massive knowledge graph, a mathematical representation of that wall. So now, go back to your complex question. Describe the chain of events leading to transformation. The AI doesn't search for the word transformation. It traverses the graph.
It walks the web?
It literally walks the web. It sees that the ghost of Christmas present shows Scrooge ignorance and want. It sees a line connecting ignorance and want to fear. It sees fear connecting to the future.
It can trace the causal path because the path is explicitly mapped out.
It's right there in the data structure.
That is so much cooler than a keyword search. And the Fast GraphRAG team actually shows this visualization. It's human readable. You can look at the web and say, oh, I see why the AI thinks these two things are connected.
And that interpretability is huge for enterprise. With standard AI, it's a black box. You don't know why it gave you an answer.
Right.
With a graph, you can audit the logic. You can point to the red string and say, that connection is wrong, or that connection is brilliant.
But, and there is always a but, with new tech building, a massive web of every noun, verb, and concept in a book, that sounds exhausting and expensive.
It is.
If I'm a company with 1 million legal documents, I can't afford to hire a digital detective to string up red yarn for everything.
You've hit on the single biggest barrier to GraphRAG adoption, the bill. Building these graphs is computationally heavy.
It has to be.
You're asking an LLM to read every sentence, extract every entity, and map every relationship. That burns tokens fast.
I saw a stat in the Fast GraphRAG notes that jumped out at me. They ran a benchmark using the Wizard of Oz.
Right. They compared the cost of indexing the Wizard of Oz using Microsoft's GraphRAG, which is, the industry heavyweight, versus their own Fast GraphRAG.
And numbers.
To process that one book with Microsoft's system costs about 48 cents.
Okay.
Using Fast GraphRAG, 8 cents.
Whoa, that's a 6x cost saving. How are they shaving off that much overhead? Is the graph just worse?
Not necessarily worse, but different. Microsoft's approach is very thorough. It uses community detection algorithms to summarize clusters of information. It writes a summary for every group of nodes. That's a lot of writing.
A lot of tokens.
A lot of tokens. Fast GraphRAG is optimized for agent-driven retrieval. It focuses on the traversal rather than pre-summarizing everything.
And they also mention incremental updates, which in plain English means what?
Imagine every time you added a new file to your database, you had to tear down your entire detective wall and start over from scratch.
Oh, no. That sounds incredibly inefficient.
It is. That's how some older graph systems worked. Incremental updates mean you can just walk up to the wall, add a new sticky note, draw a string to an existing picture, and walk away.
You don't have to rebuild the whole thing. That seems essential for anything real time. If I'm a news organization, I can't rebuild the graph every time a story breaks.
Precisely. But if we're talking about efficiency, we have to talk about KET-RAG.
Okay.
This is a paper from early 2025, and they have a really radical approach to cutting costs. They basically asked, do we really need the entire graph?
Do we? Or is that heresy in the graph community?
It might be heresy to some, but KET-RAG argues that a full graph is often overkill. It introduces noise. So they use a multi-granular indexing framework.
Multi-granular, break that down for us.
Think of it like building a house. You need a strong steel frame, the skeleton, but you don't need steel beams in every single wall.
Right.
KET-RAG builds a knowledge graph skeleton using only the key text chunks, the major arteries of the story.
Okay, so the main plot points of A Christmas Carol, the visits from the ghosts, the graveyard scene.
Right, but for the details, the color of the scarf, the name of the grocer, it uses a text keyword, bipartite graph.
Bipartite graph. That sounds technical again.
It's actually simple. It's just a lightweight index that connects chunks of text to specific keywords. It's much cheaper to build than a semantic relationship.
So it's a hybrid approach. Heavy lifting where it matters, light lifting where it doesn't.
Exactly. And the results are staggering. They claim to reduce indexing costs by over an order of magnitude compared to Microsoft's GraphRAG.
An order of magnitude. Wow.
But here's the kicker. They claim to improve the quality of the answer by up to 32.4%.
Wait, cheaper and better. Usually in engineering, you pick two. Fast, cheap, or good. You're telling me they got all three.
It turns out that in GraphRAG, more isn't always better. If you map every single relationship, you get a dense graph. It becomes a hairball.
Right.
The AI gets confused by too many irrelevant connections. By focusing on the skeleton, KET-RAG keeps the signal clear.
That's a great point. It reminds me of a subway map. A subway map is useful specifically because it ignores the actual curves of the tunnels and the streets above.
Yes.
If it showed reality, it would be unreadable.
That is the perfect analogy. We're moving from throw everything into the graph to build smart, lightweight skeletons that function like that clean subway map.
Okay, so we've got structure and we've got efficiency. We solved the cost problem. But there's one more frontier in this stack of papers, and this is the one that starts to feel a little sci-fi.
It does.
We're talking about memory. Real human-like memory.
This is where we look at HippoRAG 2. The title of the paper is literally From RAG to Memory. They explicitly state that standard RAG hinders the ability to mimic the dynamic and interconnected nature of human long-term memory.
Because human memory isn't just a hard drive where we file things away alphabetically. It's associative. If I say Apple, you might think Pi or Isaac Newton or iPhone, depending on the context.
Exactly. That's associative memory. Standard vector search, the Corcel plus F method, struggles with that. It looks for similarity, not association.
So how do they fix that?
HippoRAG 2 solves this by using an algorithm called personalized PageRank.
PageRank. As in the algorithm Google used to organize the entire internet back in the 90s.
The very same mathematics. But instead of ranking web pages, it's applied to your internal memories, the nodes in your knowledge graph.
How does that mimic memory, though? I don't rank my memories by SEO.
Well, think of it this way. Imagine a random walker stepping through your brain. If you are thinking about Scrooge, the walker is standing on the Scrooge node. Now, where is it most likely to step next? Probably Marley or money. It's less likely to step to Victorian sewer systems, even though that's also in the book.
Okay, I follow. The walker follows the strongest connections.
Personalized PageRank calculates those probabilities based on your current context. It allows the system to wander through the graph in a way that mimics how our brains drift from one related thought to another.
So it helps with sense-making. It's not just retrieving a fact, it's figuring out what else is relevant.
That's the idea. In their tests, HippoRAG 2 showed a 7% improvement in associative memory tasks over state-of-the-art models. It's moving from retrieving a document to remembering a connection.
That feels like a pivotal moment. We're not just searching a database anymore, we're traversing a mind.
And to tie it all together, we have to mention GReasoner. This source takes it a step further and introduces a graph foundation model.
A foundation model for graphs, like GPT is a foundation model for text.
Correct. Usually we use an LLM, which is text-based, to look at a graph which is structure-based.
Right.
They remain separate. GReasoner uses a quad graph, a standardized four-layer abstraction, to unify them. They argue that to really reason, the model needs to understand both the topology, the shape of the graph and the semantics, the meaning of the words, simultaneously.
It's trying to merge the left brain structure and logic with the right brain language and meaning.
And that is the holy grail, unified reasoning.
It's incredible how fast this is moving. Just a year or two ago, we were impressed that a chatbot could summarize an email.
Yeah.
Now we're talking about personalized PageRank algorithms mimicking associative memory on knowledge graph skeletons.
The pace is relentless.
Right.
But look at the trajectory. We started with flat text search. We realized it was too scattered. We built graphs to connect the dots.
Then we realized the graphs were too expensive.
So we invented Fast GraphRAG and KET-RAG to make them cheap and efficient. And now, with HippoRAG and gReasoner, we're using those efficient graphs to simulate actual thought processes.
So what does this mean for the listener? Why should they care about GraphRAG unless they are a data scientist?
Because the Control+F era of AI is ending. If you are using AI to analyze data, legal contracts, medical research, or even just your own personal notes, you are about to get a tool that can connect the dots in a way you might miss.
It's the difference between asking, find me files mentioning Project X, and asking, what are the hidden risks in Project X based on the emails from the engineering team and the budget reports from finance?
That's it. It finds the patterns that are too scattered for a human to see. It turns information overload into structured insight.
I love that. It's not just about finding the needle in the haystack. It's about understanding how the needle got there, who put it there, and what thread is attached to it.
And why the hay is flammable.
Right.
But this raises a provocative question to end on.
Oh, I like a good provocation. Lay it on me.
We've talked about how these models are using associative memory and reasoning to navigate these graphs. They're tracing paths, making connections, and prioritizing information based on context.
Right. It feels remarkably human.
So at what point does retrieving information stop being a database query and start becoming actual thinking? If the process of retrieval is identical to the process of association and deduction, is there a functional difference between searching and thinking?
That is going to keep me up tonight. We tend to think of memory and thinking as separate things, but if you remember the connections, you are thinking. We are building the machinery of thought, one graph node at a time.
We certainly are, and the line is getting blurrier every day.
Well, on that slightly terrifying but awesome note, we're going to wrap up this deep dive. Check out the show notes for links to Fast GraphRAG, KET-RAG, and all the papers we discussed. Go look for the hidden connections in your own data. You might be surprised what you find. Thanks for listening.